Hey everyone, welcome to hok'stutoring. So today we're going to be doing a tutorial video as opposed to a topic video which we did last week for hypothesis testing. So more specifically, we're going to go through question 8 on chapter 16b of your textbook, and it's regarding a two-tail test for hypothesis testing. So before I get into the question, I just want to give off a little bit of a quick revision. So for hypothesis testing in Special Maths, we have to do a 3-step process. So the first one is you have to jot down what your null and your alternative hypothesis is. That's step number 1. Step number 2, you have to do the test, the actual test itself. Find the p-value more specifically, which is essentially just saying find the probability of something happening. And step number 3 was you have to compare it against the significance level. So is p-value bigger than the significance level, or is p-value less than significance level? If it's less than significance level, which in this case, if you read through the question, most of the time it should be 5%, then if p-value is less than that, we reject the null hypothesis, which we had in step 1. So that's pretty much it for the revision. So let's have a go at question 8. According to your records, the average starting salary for university graduates in a certain state is 55,000 with a standard deviation of 5,000. So I have a population, which in this case is the university graduates, and the average salary, which we call the mean, is $55,000. So $55,000, and standard deviation of 5,000. So yeah, not everyone's going to earn 55,000 exactly. That's why you have your spread, your standard deviation. Right, the vice-chancellor of a large university wishes to determine whether their graduates earn more or less than this. So what that is saying is your alternative hypothesis. He wants to determine, is it true that it's just 55,000 or maybe it's something else? And to do that, he tests. So this is where the test starts. A group of 50 randomly selected graduates are surveyed. So that means n equals 50. And the average salary is found to be 53,000. So you test 50 students in that population, 50 in there, and you found that the average salary is actually only $53,445. So for those 50 students, and we want to determine, right, is that 53,445, it is indeed less than 55, is that enough to say that the average salary for university graduates has changed? So that's why we do the hypothesis testing. So in this case, let's go through step number 1, the easiest out of all of them. So to start step number 1, you write down your null hypothesis, which in this case is your original, your $55,000, right? So the university graduate mean 55, and your alternative is it has changed. So graduates earn more or less than this. So it doesn't matter whether you have more or less, it's just different, it's changed. So in this case, don't put the big or small sign, just put it's changed. It's not 55,000 anymore. So these two values should always be the same, pretty much. If that's 55, this should also be 55. Okay. Moving on to step number 2, we need to find our p-value, right? So how do you find your p-value? So this is a two-tail test. Just remember, whenever you have a two-tail test, it means you can take either tail. So either the tail that is on the left or the tail that's on the right. So to calculate your p-value, so you have to find the probability of you obtaining a sample average. So out of those 50 students, your sample average was less than 53,445, given that the mean was originally only $55,000. So what was the probability of your sample having an average of 53,445 when the entire population average was 55,000? So you want to find, was that a small chance or was that a high enough chance to actually get it? So in that case, you do this, and you also have to multiply by 2. Now the reason why we multiply by 2, this is a two-tail test, is it doesn't necessarily have to be smaller than 53,445. So it doesn't have to be on the left tail. It can actually be bigger than some other value on the right tail. Because remember, we're not testing whether the salary has decreased. We're testing whether the salary has increased or decreased. So it does either way. So that's why you multiply by 2. So to do that test, it's just 2 times your probability. So we change this to the z value. Remember, you have to do normal distribution in this case. So Z 53,445 minus 55,000. So remember, it is z equals to x bar minus mean divided by standard deviation over square root of n. If you're not entirely sure about this, check my video on normal distribution for specialist maths and you'll find out how this formula came about. Okay, so we have 2 multiplied by the probability, which in this case, we have to fill it in first. 53,445 minus 55,000 divided by standard deviation, which is 5,000, and over square root of n, right? So in this case, square root of 50. Cool. So you find that first, and your answer, it should be 2 multiplied by 0.1394. And of course, you multiply that by 2 and you get 0.0278 or 279 to be specific. So that's pretty much your probability, your p-value. So what that means is, okay, I had a 2.79% chance. So given that the mean was 55,000 for the entire population, the mean salary, I had only a 2.79% chance of obtaining this sample with an average of $53,445 as the average salary. So that's a fairly low chance, only 2.79%. So that's when you have to do step number 3. You have to determine, right, was I just unlucky in obtaining that sample, or has the actual mean, the population mean, has actually changed? So it's determined, okay, does that mean I was unlucky and I just picked, you know, a sample that didn't really represent the population, or has the population mean actually changed? So has the salary actually changed? So that's what we're doing. So that's when step 3 comes in. You compare this value, this p-value, to the significance level, which in our question is 5%. Use the significance level 5%. So 2.79, 0.0279 is smaller than 5%. So that means it was a low enough chance for us to consider. So given this question, it was a low enough chance for us to believe that the mean has changed. So if this is smaller than the significance level, then it has changed. If it's bigger than significance level, then we're just unlucky. We just picked a sample that didn't represent. So that's what step number 3 does. P-value less than significance level. Therefore, what we do is reject H0. So reject H0 right there. Okay. Reject H0 and you follow up that with another sentence. There is sufficient, so just excuse my bad handwriting. There is sufficient evidence at the 5% level. So there's sufficient evidence at the 5% level to conclude that, and then you go back to the question, you read the question, what is it trying to say? The average starting salary for a graduate from this university is different from the rest of the state. So to conclude that the average salary of this university is different from the rest of the state. So that's pretty much it. So that's how you finish off your hypothesis question. If you want to be really specific, you can also add here, instead of saying there's sufficient evidence, you can go look at your line, so how strong your evidence is on your textbook, and if it's less than, in this case, if it's 2%, so that's between your 1%, 0.01, and 0.05, so that is good evidence. So you have good evidence at the 5% level. You can say good instead of saying sufficient, or it's up to you. Make sure you check with your teacher to be sure about this. But aside from that, guys, that's how you do your hypothesis testing. Step number 1, go through your null and alternative. Step number 2, find your p-value, and remember to use the normal distribution formula for sampling. And step number 3 is you compare to your significance level, your p-value to your significance level, and you should be able to conclude your answer at the end. So that's how you answer this question. Thanks for watching this video, guys. and I'll see you next week.